Hey guys, so in this video we'll work out an example related to work done and the work kinetic energy theorem. So this example, is from the book Fundamentals of Physics by Halliday, Resnick and Walker. This is chapter 7. So in this example you have a block and the block is being moved by two people. Okay, so there is a force F1 on the block and a force F2 on the block. Now the displacement of the block is in this direction. That's the displacement. And there are of course other forces acting on the block, so that's the normal force and weight of the block. Okay, well, let's call this Fg so as we don't confuse it with work. Okay, so what do we need to find? We need to find the work done by these forces. What is given is the magnitude of F1, that's 12 newtons, the magnitude of F2, that's 10 newtons, the distance the block moves is 8.5 meters, and these angles are given. This angle is the angle that F1 makes with the horizontal is 30 degrees, and the angle that F2 makes is 40 degrees. Okay, so these angles are given. This is all the information we have. What we need to find is the total work done by all these forces on the block, and we also need to find the velocity. And also it's given that the block starts from rest, which means that the initial velocity of the block is 0. Okay, so how do we find the work done? As we discussed in the previous video, in this case, since we know the angle, we know the magnitude of forces, we can just use work equals Ft cosine theta. So let's look at the work done by the force F1. The magnitude of F1 is 12 newtons, theta 1 is 30 degrees, and the displacement is 8.5. So 12 newton times 8.5 meters times cosine of 30 degrees. So that gives us, if you plug in the numbers, you get 88.33 joules. Let's emphasize the plus sign, because plus sign means adding energy to the system. So this force is adding energy to the system. And the work done by F2 is F2 d cosine theta 2. So theta 2 is 40 degrees, okay? And F2 is 10 newtons, and d is 8.5 meters. So if you plug in all the numbers, you get plus 65.11 joules. So that's your W2. Now the work done by the normal force and weight is going to be what? You guys should know what the answer should be for these, right? It's an easy question. So the normal force makes an angle 90 degrees, and so does the weight. Okay, so the work done, because theta is 90 degrees, work done by the normal force is 0, work done by gravity is 0. So the total work done by all the forces, W1 plus W2 plus W normal plus WG, when you add all these numbers, you get 153.4 joules. Okay, so just something on the side, joule is the unit of work, so 1 joule is 1 newton meter. Okay, so the total work done is 153.4 joules. Notice that both of the forces are adding energy to the system. They both are doing positive work. If let's say F2 was in this direction, let's say you add 90 degrees to this, you push you move F2 in this direction. So then F2 will do negative work, and then you have to subtract the 2. Okay, it will mean that F2 is trying to, while this guy is trying to move in this direction, F2 is trying to slow it down. So the total work will be less. Okay. Now, how do we find the final velocity? So we use the work kinetic energy theorem, right? The work kinetic energy theorem says that total work done is equal to the change in the kinetic energy of the system. So we know that the initial velocity of the block is 0. Okay, this is 0, which means that since this is k final minus k initial, this is 0 because kinetic energy is half mv squared. So we get W total equals half m v final squared. So v final is square root of 2 times W total divided by the mass. So if you plug in the numbers, you get v final equals 1.17 meters per second. So that's your v final. So after 8.5 meters, the block will be moving at this velocity. So if let's say this is negative, then you can see that you get a smaller velocity because F2 is doing negative work. But in this case, since they both are positive, you get a greater velocity. So that was it for the problem. If you have any questions, post them in the comments. Thank you for watching. Bye.